everybody. How are you doing in Leicester? Good to see you all.
Good morning, Tim, and I suppose just to say good morning, given that you're off the Florida coast undersea. Welcome from the National Space Centre in Leicester. We've got a really big audience here of the general public, some primary school, secondary school students, some A-level physicists. And I just wanted to start by asking, Tim, you're a European Space Agency astronaut. You've been, from my reckoning, 9 days undersea at the moment, working with other astronauts from NASA and the Japanese Space Agency. What is it about being undersea that you're practicing and it's so vital for your training as an astronaut?
That's a very good question, and it's one that we're asked quite a lot. Actually, this gives us a fantastic analogue to spaceflight for a number of reasons. Firstly, the crew of 6 here, we're confined in Aquarius. It's our life support vessel. We don't have any option to evacuate to the surface. We're so saturated with nitrogen, we've been down here for so long, that we would suffer from decompression sickness if we were to. So there's an element of risk, much like there is on a space mission, where you're isolated and you don't have any quick option for recovery. Also, we're of course using the water for neutral buoyancy. So that's the best thing that the water gives us to. We can weigh ourselves out as if we're in a weightless situation. And when we're working with our jetpacks or our submersibles or our tools, we can then better evaluate what's going to work on an asteroid and what isn't.
Thanks very much, Tim. And I also know that with other European Space Agency colleagues, last year you were isolated for nearly a week in an underground cave complex in Sardinia. How does being undersea compare to being underground in terms of your training?
It's amazing the kind of things that you get up to as an astronaut that I never dreamed of. Living in a cave for a week and living underwater for what will be 12 days. The two missions are actually fairly similar in terms of isolation. Because I think when I splash up on Friday with the rest of the crew, it's going to be a bit of a sensory overload when you see the sun again and you smell fresh air again for the first time in such a long time, as well, of course, being able to take a decent shower and eat some decent food. But in terms of isolation and getting on as a crew and learning how to work together towards a common goal, doing scientific research, these are great analogues, and the cave environment and the underwater environment are actually fairly similar in that respect.
Thanks very much, Tim. You'll have to forgive my smiles because while you were talking there, I suppose you get used to it. There were some very large fish that were just popping up over your shoulder and really reminding us of where you are under the seas. So I want to move on to a couple of questions we've had from the general public, Tim. The first one was from Willoughby Chase. He emailed us on Twitter and he asked, when you tell people you're an astronaut, what's their first reaction?
It's something I actually try not to bring into conversation as much as possible, because I'm normally met with sort of silence and and people wonder if I'm actually telling a joke or not. But actually, people are absolutely brilliant when they find out what I do for a living, and they're always fascinated to ask questions, and I always enjoy talking to people about what it's like doing the job in training, and what I've learned from all of the astronauts I've met who've been into space and conducted short and long duration missions. So I love passing those messages on, and I'm always, I'm really fascinated to meet people and enthralled about how many people there are who are interested in human spaceflight.
Just one more question before we come on to the students' questions. We have an author, Keith Mansfield, on Twitter, and he was very jealous. He wanted to swap places with you, but what he actually wanted to ask was, you're a former helicopter test pilot, you're now an astronaut. If you could have any other job in the world, what would it be?
I can't honestly think of any job that is better than the one I'm currently doing. The diversity that is involved, the people you meet, the subjects we study, and the mission we're trying to accomplish, it's all absolutely fantastic. It really is so far the pinnacle of my career.
Thank you, Tim. I just want to introduce the first. We've had a number of A-level physics students who've been doing a really intense series of Space Academy masterclasses all day, so they're not physics out, but they've still got loads of questions they want to ask you. And if I can introduce the first one, I'll ask her to introduce herself and her question.
Hi, Tim. My name is Gemini Mystery, and my question is that we carried out an experiment earlier today to investigate the effects and differences in pressure on a marshmallow, and it didn't fare too well. So what effects personally have you felt on your body?
Hi there, great question. It's funny actually because last night we were doing some filming of a video with a bag of marshmallows that we brought down with us to show how compressed they were, how compressed the bag was, and how compressed the marshmallows have become. But effects on the body, actually, the biggest effect at the moment is on my ears because we currently have 8-foot seas above us. For the last 2 or 3 days we've had some rough seas and every time the swell builds up, the pressure inside Aquarius keeps changing, and as the pressure changes, our ears are constantly popping. So as I'm speaking to you, I'm constantly trying to clear my ears because of the swell. Other than that, there's been really no effects on the body, but we've all noticed that it's quite hard to whistle because of the higher pressure down here. So that's probably about the most noticeable thing.
Okay, thank you.
Okay, and we have another question as well from another A-level student.
Hi, my name's Adam. I was wondering, what problems have you encountered, and has the high pressure affected any of your instruments?
Hi Adam. Thankfully, problems have been few and far between. Everything's pretty much running smoothly and running to plan. The high seas, as I mentioned, have caused some electrical problems, but we've easily resolved that, and most of the equipment is all working normally. In terms of instruments, everything again we brought down. We kind of knew the environment we were coming to, so we made sure that it was going to cope with the pressure changes. But you'll notice, for example, we're all walking around with tablet PCs. One of the reasons for that is because rotating hard drives down here are very unreliable because of the humidity and the pressure. Solid state memory, however, is very good. So these are great tools for working with down in these high pressure environments.
Thanks.
Okay, thanks, Tim. And we've got one final physics-related question before, if we have time, we'll open up for a few more.
Hi, Tim. I'm Charlotte. My question is, in space, bone density decreases and osteoporosis is a risk. What risks are associated with increased bone density from being under the sea?
Hi Charlotte, that's a great question. Increased bone density under the sea. I don't know what the risks are actually. I should think that because we're doing this for such a short duration that it will only be very temporary and will return to normal within a matter of hours when we get back to the surface. But I must admit, an increase in bone density being under higher pressure is something I'll have to look into. Certainly very interesting. But you mentioned that about spaceflight, and that's what's so amazing about the human body, I find, is how quickly and how readily it does adapt to new environments, both in zero gravity up in space and, for example, down here where we can quite happily live and work.
All right, thanks.
Okay, thank you very much, Tim. Tim, how are you doing for time? I know that you've got a really busy schedule with a final practice EVA later on this afternoon, your time. I just wonder how much more time we have with you.
We've got at least 10 minutes, so we're doing good. I've got another activity after this, but currently going on outside, we've got 2 of our aquanauts who are in the water exploring the asteroid surface. They're using jetpacks today. They're using translation lines and metal booms, and they're doing a geological survey of the asteroid and working out how best to collect scientific samples and return them.
Thanks very much, Tim. Now, we had some questions from our A-level students. We've also got a lot of other students here at the National Space Centre. I just wondered, guys, do you want to give Tim a wave? You can just about see them there. I think the camera is panning in. I'm thinking for our younger students, Tim. Our A-level students have already decided they're going on a path into science and engineering, and it's fantastic. But for our younger students, have you got any messages you wanted to share as a former test pilot, as an astronaut doing this incredibly exciting job?
I would just like to say that, you know, science and engineering, mathematics, technology, it opens up a whole world of adventure. It's fascinating to study. It also opens the door to fascinating careers, not just being a test pilot or being an astronaut, but in engineering as well, and in high-tech environments. There's just so many different things that you can go and study. I've loved studying science all my life. I still do. I pick up science books. I enjoy reading about it. I've got the privilege of working with some of the great scientists that we have around today. For example, in the water right now is Professor Steve Squires, who's actually in charge of the 2 rovers which are on Mars at the moment, Spirit and Opportunity. So there's a whole wonderful array of different careers you can have in science, and I would just say go for it.
And looking at your training, Tim, what for you personally was the most challenging thing? I mean, you've had an incredible background as a pilot, but there must have been some parts that really took you into new areas and really pushed you. I wondered for you, what was the most challenging part of your training?
I have to be completely honest here and say, whilst I enjoy science, I'm no linguist, and learning Russian for me has been the hardest thing to do. I do enjoy it, and I've got several new Russian colleagues who I enjoy communicating with, but certainly that's been a struggle, more so than learning anything to do with the astronaut role.
And it's interesting you say about learning Russian, because what I think a lot of people aren't aware of is that the European Space Agency astronauts will be in space for 6 months at a time. So thinking, Tim, coming to the end of your 11-day mission, what do you think it's going to be like to be isolated, orbiting the Earth for 6 months? And I apologise, we've had to lose some of the students who've given you a goodbye wave, but we've still got quite a few people here. 6 months orbiting the Earth. I mean, how's that going to compare with the 11 days of your undersea mission?
Yeah, I mean, that's a great question, because in the kind of mission we're doing at the moment, it's high-tempo operations. It's very much like a shuttle mission, a sort of 12-day shuttle burst where there's a lot of activity, you work very hard, you work long hours, and you get the job done and you achieve as much as you can in a short time. You can't keep up that tempo over 6 months, so you have to go on to a more normal routine with weekends where you actually have time off, time to relax, time to communicate with friends and family, etc. So there are definitely differences, but it's psychological well-being during these long duration missions is very important, and so we always have to consider that and make sure the crews are keeping well fed, well slept, and in touch with friends and family. But I think having, looking out your cupola window and seeing the Earth orbiting below you, well, it's going to be a big boost anytime you need one.
Absolutely. You'll have a view that very few human beings have had the privilege of getting. If we have time, Tim, I just want to open up for any other questions that we have in the audience. We've got quite a few other young people here. Do you have time for 1 or 2 more questions, Tim?
I certainly do. Yeah, please go ahead.
Okay, just looking to the audience, do we have any questions? Oh, we've got somebody's hand shot up over there. Would you like to come forward? I'm putting them on the spot, Tim, so you'd have to apologise. So if you'd like to come forward to the microphone here and introduce yourself and ask Tim your question.
Hello, my name is Hannah. I was just wondering, do you use any forms of radiation with the work you're doing underwater at the moment?
Hi Hannah, we're not using any forms of radiation for this work. No, we're kind of looking at what tools and techniques and procedures are going to be best suited for asteroid exploration. And we're actually working with some quite sort of chunky pieces of equipment when it comes to things like the jetpacks and extendable booms and translation lines. It's all fairly physical, it's all fairly manual work with hammers and drills and that kind of thing. I'm sure that radiation equipment will be used for asteroid exploration, and that's something that possibly will be introduced into further NEEMO missions.
Thank you.
And do we have any other questions from the audience as well? Yeah, would you like to come up and ask?
Hi Tim, my name is Matilda. My question is, you mentioned the high-pressured environment and the kind of equipment that you take on board. So I just wanted to know how important is it for your equipment to be ultra-lightweight, considering you're training to go into outer space with no gravity?
Hi Matilda. Yeah, it's really important obviously in terms of cost of getting into space, so that the lighter the equipment can be, then the cheaper it is to get it into orbit. And that's really the driving factor. Once it's in orbit, then clearly it doesn't matter. If something is very heavy, it still is going to have inertia though, so that's considered, for example, when we're doing spacewalks and we're on the end of a robotic arm. If you're maneuvering something with a large mass, then you can only go at a certain rate because of the inertia you're going to have. Down here, of course, we don't really have that problem. We just have to worry about the pressure aspects.
Great, thank you.
Okay, Tim, I'm just thinking, as you draw to the close of your 11-day mission, you've been 9 days in the habitat. Now, we can see you at the desk and we can see the porthole. Could you just give us an idea of how much space has been available to you? Because it's a lot more cramped than a lot of people might realise.
It is a little bit tight, but it's amazing how quickly you get used to the small spaces. It's like a small submarine, really. It's certainly no bigger than a single-decker bus. It's about 15 meters in length, maybe about 3 meters in diameter. So we sleep in a small bunk room which has got 6 bunks, 3 either side. This is our living area. This is the only table in the habitat where we can eat, we can prepare our food. And then next door we have a control room where all of our scientific equipment is and where we're controlling the missions. And then we're out into the wet porch. And the wet porch is just an area where we have all of our diving equipment, and we have a small sort of 8-foot by 2-foot entrance into the water.
And am I right in thinking that the diving suits that you're using are full diving suits? Because from what I understand, you're actually having quite an important press conference during one of your spacewalks this afternoon. And as somebody who does scuba diving, we've always got a regulator in our mouths, but you've got a full pressure diving suit. Am I correct thinking there?
Well, we've got the proper commercial diving helmets. We're just diving in traditional wetsuits. But it would be too difficult and too expensive to have fully pressurized spacesuits down here. Although we do use fully pressurized spacesuits in the swimming pools in the Neutral Buoyancy Laboratory in Houston, and also at the European Astronaut Center in Cologne and in Russia. But the commercial diving helmets are great because what it does is it gives you a feel as if you're inside a space helmet. And it gives you as much air as you want to breathe, so we can be out there for up to 5 hours we were the other day doing these dives, and we also have great communications. So that is a kind of change to what would be normal diving operations.
And at the end of this mission, Tim, when you're back on the surface, and you mentioned that you can't just come up, you've got to decompress to let the high pressure gases out your system. So for the end of this mission, with so much training, what's next on your training schedule?
Well, next for me on my training schedule is to support the ESA's Caves activity again this year. So I'll be supporting that from back in Cologne, but I'll be helping out. And then I'll be back to Houston again later in the year to learn more about the USOS operator system. Now that's part of this, which we call the US segment. We have to get trained up to quite a high level on all areas of the International Space Station, the Japanese, the European, the American and the Russian segments. So that training continues whilst we're waiting for mission assignments. So that's what I'll be working on. I'm also going to be supporting Luca Parmitano, who is in my European class of 2009. He will be launching next year, and I'll be his primary Eurocom communicator. So I'll be the guy who's talking to him from the ground and helping support him on his mission.
And there's such a big focus on training and training for years and years because of in your 6 months in space, you're going to be doing experiments for researchers from all over the world. I'm just wondering, what's it been like to have to take on board so much of the science that's maybe outside your own specialism? It sounds like a pretty heavy workload.
It can be a heavy workload at times, but it's a very enjoyable workload, and as I said, it's kind of a bit of a hobby and a passion for me anyway, so I'm always fascinated to learn new things and to learn the science behind the instruments and the equipment we use. And also, of course, we have an enormous support structure, and that's the thing never to forget about the job that we do is I'm sat here and there's 6 of us down here in Aquarius at the moment, but we have a support structure of about up to 80 to 100 people who are on the dockside in Key Largo from mission control there. And from the International Space Station, you have a support team of thousands. So you always have great support, people to talk to, people to keep you informed, and people to help you out with the science being conducted.
Thank you, Tim. Now, I'm just looking. I do feel a bit guilty about hogging your time, but I've probably got time for one more question. If there's anybody else who had a question. We have somebody at the back, if that's okay. Would you like to come forwards? As I say, Tim, if we are getting greedy with time, please let us know. I know that you've got a packed schedule, but we can squeeze one more in.
Hi, Tim. I'm Will. I was just wanting to ask, in our physics masterclass, we watched an experiment where you had a helicopter and you were lifting up sweets, and because it was the greater dense pressure, you could lift more sweets down there than in the harbour. Have you done any other experiments in order to explore the high pressure environment that you're in?
We had quite a lot of fun last night, Will, doing some great experiments. One of them was Mentos and Coke. which of course, I don't know if you've ever tried that up on the surface, but when you put Mentos into Coke, there's a pretty spectacular reaction. Well, down here, virtually nothing happens. You can shake a can of Coke, open it, or any sort of fizzy drink, open it, and the CO2 remains in the water. So that's something that's quite interesting to do down here. We've also been looking at Bernoulli's theorem. We've been looking at the size of foam and table tennis balls to see if they've been compressed by the higher pressures. We've tried blowing bubble gum. Our commander, Dottie Metcalf-Lindenberger, she tried blowing bubbles last night. So we've done all sorts of funny things to do with the science under pressure.
Thank you very much.
Tim, you mentioned about Dottie being one of your NASA colleagues, and we've got colleagues from the Japanese Space Agency. You talked about having to learn Russian as well. Just how much of your time is spent outside Europe and working in all of these other places? Because certainly it sounds like it's a job with a lot of travel, but you've got to be very flexible with working with so many different nationalities.
Yes, there is a lot of travel involved, but that's one of the great things about the job. It's always interesting to go and meet new people and go to new places, but it also really describes the environment with human spaceflight, manned spaceflight. It is an international endeavour, and that's where we're going in the future. No one country is going to be able to make those big, bold steps to go and explore Mars, and maybe in the future even beyond Mars. So we have to do this as an international collaboration, and that has worked well for many, many years, and it's still working well today, and it's one of the great things about manned spaceflight.
Thank you, Tim. Now, you mentioned about rehearsing missions, not just to the Moon and Mars, but to asteroids. And a lot of people might raise their eyebrows. I wonder if you could just explain to the audience what is so interesting about asteroids, and why are we so concerned about trying to send human beings to asteroids as well as planets?
Well, I've been learning as well in the last few months once I got assigned to the NEMO mission, and I've had some fascinating presentations about them. There are an awful lot more asteroids than we originally thought, and actually we're learning more about how many there are at an exponential rate. So there's at least over 500,000 asteroids that are just within the vicinity of Earth, and of those about 1,500 are potentially hazardous objects. So the more we learn about these asteroids, it's good for us to understand them. There's also some great science to be done, because the asteroids are basically cover 4 billion years worth of solar system development and history. And all of the rocky planets were formed by clumps of rock coming together. So the remnants that are left over in the solar system can tell us an awful lot about the formation of the universe. There's also some natural resources on asteroids that will be useful for us to study, and potentially in the future even able to harness these.
And could it also be the case, I know a lot of people are worried about asteroids and the chance of hitting Earth. We all remember the cheesy Hollywood films from the 1990s, Deep Impact and Armageddon. Could it also be possible that humans going to an asteroid could help knock it off course and stop it from colliding with Earth? Or is that Hollywood science fiction and too far?
It's certainly not Hollywood science fiction and too far. It's something that is being discussed very seriously. I think that at the moment the level of knowledge we have about asteroids is pretty good, and so a robotic mission would probably be the primary objective for actual planetary defense. But if a robotic mission were to fail, or if something was spotted in a time frame that we weren't able to accomplish it by a robotic mission, then absolutely a manned mission is also an option. And I'm afraid I'm going to have to wrap it up there. I've run out of time. So it's been great talking to you this morning, but I'm going to have to get back to the asteroid exploration that's going on the ocean floor right now.
Absolutely. Well, thank you very much for your time, Tim. It's been a pleasure and an absolute privilege for us here at the National Space Centre. If we could just finish with a round of applause for the United Kingdom's ESA astronaut, Major Tim Peake. As we finish with a goodbye wave as well, guys. Thank you very much, Tim. It's National Space Centre signing out.
Thanks, guys. Bye-bye.